Hey there, my name is Craig Tappe. I work on the sales engineering team here at Accumold, and today I'm going to talk to you a little bit about micromolding, thin wall molding, and specifically thin wall cannula molding that we really specialize here at Accumold. So we'll go ahead here. I have a quick presentation to share. This first slide kind of shows you what really micromolding is. That's what we specialize here at Accumold on. Micromolding can mean a wide variety of things. It can mean molding very small parts with micro-sized features, micro-tolerances, or just overall micro-sized footprints. We also specialize in somewhat larger parts that have the same micro features or micro-tolerances. Some of our other core competencies are thin wall molding, which I'll be talking about today, over molding, and two-shot molding. So I'll kind of get into our thin wall molding a little bit. This first slide you can show a case study that we did. So at Accumold here, we have a large innovation team that dedicates their time to really improving our capabilities and setting us apart from a lot of other molders out there. This component you see here on the screen is not actually a customer part. This is one that we developed at Accumold specifically to test our thin wall molding capabilities. So you can see this part has a very thin aspect ratio. It's about a 3,000 thick wall, almost an eighth of an inch long. What we did here is we built a tool to mold this part. We sampled the 11 resins you see here on the screen. And before we even sampled these, what we did was we reached out to our material suppliers and we asked them what they thought would happen when we sampled all 11 of these resins in our mold when it came to producing this very thin-walled component. What happened was all of them said for every material, there's no way we could do that. We would have to start out 5 times thicker and machine the part down, which is just not feasible when you're trying to produce parts in high volume production. You can see on the next slide here the results that we got from the study that we performed. You can see for the top materials we were able to fill out the complete aspect ratio. The study was a huge success for us with those materials. There's also some materials we knew we weren't going to get very close on. So you can see the peak at the bottom of the screen. A lot of people refer to peak as molding with concrete. It's very hard to process. It's very hard to mold with. Some of the parts that I like to look at on the screen, though, are the nylon and the polycarbonate, kind of shown in the middle of the study here. So you can really see how those flowed a lot differently throughout the cavity. The nylon filled out through the center a little bit better, and the polycarbonate filled out around the edges. We use data from studies like this to really optimize our manufacturing, our mold building process, really heat and cool areas of the cavity and vent areas specifically for the resin that's chosen by our customers. So our thin wall molding really brings us into what I'd like to talk about today, and that's thin wall drug delivery cannula molding. So what really led us to get into this about 5 years ago was we were customer driven. One of our large diabetes wearable customers reached out to us with a problem, and we wanted to be the ones to provide a solution for them. Their problem was in the insulin sets that they use to deliver the insulin into the patient, the cannulas that are inserted into the skin are very expensive to manufacture at high volumes and also very problematic in the device. So what these are currently is there a piece of polyimide tubing that's extruded. There's a tip chamfer ground onto the tubing, and the back end of the tube is actually flared out. So already just in the thin-walled piece of the component, there's a lot of cost. So in addition to that piece of polyimide tubing is then glued onto a separate hub piece, which also introduced extra cost to the component. So that was the problem our customer had. There's a lot of fallout with that manufacturing method, and it causes a lot of problems with the patients as well. Sometimes the glue fails, and the thin-walled polyimide tubing actually sticks in the patient, which causes lots of issues for our customers. So they were looking for a solution. We worked with them, and what we did was wanted to manufacture a small single-piece molded cannula that would be able to function a lot better for the patients, most importantly, but also reduce the cost of the device exponentially. What we did was look for a solution to that by producing a single-piece molded cannula. So you can see here on the next slide kind of where we started out 5 years ago. So we knew we could do some very high aspect ratio components just by our experience on past parts. This slide here shows an entry cannula that we molded for eye surgeries. So this component is inserted into the patient's eye. The surgeons doing the procedure then move their tools in and out of this molded cannula during the procedure. So this part right here has an aspect ratio. It's about 1/4 of an inch long. It's a 4,000ths wall thickness. And you can see we mold a sharp chamfer on the end of the product because insertion force is really important for this specific application. You can see a very critical part, very thin wall. We did it very well at Accumold. Really gave us confidence to move into molding these cannulas at higher aspect ratios for a lot of different markets. So you can see next on the list here of our processes, we prototyped a thin wall cannula for a drug delivery device that delivered a drug used for cancer treatment. So you can see on this one, the aspect ratio is really about the same. It's a longer cannula, but the wall thickness goes up to 6,000ths of an inch thick. We molded this one with polypropylene. It has a very small taper, somewhat similar to the tip chamfer on the eye surgery cannula that we molded, which is also very important for insertion force. You can see the cannulas are very flexible when it comes to design. This one has a couple of retention features on the proximal end of the cannula. Things like that are very easy for us to add, so the cannula can easily be inserted into your current devices or any new devices. The cannula we're now molding for our drug delivery devices in very high volume is the one you see on the screen here. So this is our smallest aspect ratio yet. We go out to about 3/8 of an inch long, all the way down to 4,000ths thickness. We think we can go even lower than that depending on the specific material and part geometry. This gives us a lot of capability to solve a lot of our customers' problems when it comes to the high volume drug delivery market. Lots of people are looking to reduce the cost of their device and really make a lower profile, more effective design for the end patient. That's what our technology gives us here. Lots of different research and testing went into producing this cannula. It took us a long time. So materials and design and aspect ratios are the three real critical items for success when it comes to these thin wall cannulas. What we did was we tested a few different methods on manufacturing these cannulas. We tested these in a couple different molding platforms that we have here at Accumold. One is what we consider our small molding platform, which is just a standard Sumitomo 30-ton press. You see all over across different molders in the US here. And the other was our micro molding platform, which we developed here from the ground up at Accumold, specifically for very micro-sized features and thin walls. So we tested the product on both of those systems. We really struggled on the larger Sumitomo platform that a lot of other suppliers use for their micro-molded components. It struggled. We had some flash, some non-fill. We kind of fought conditions as we tried to process out our tooling to mold the thin wall. Then we moved to our micro-molding platform, which is specifically designed for components like this. And we were very successful figuring out different methods to heat and cool our tooling and also process the materials as we tried to troubleshoot and find a solution to mold this high aspect ratio thin wall cannula. We have several different solutions. So we prototype thin wall cannulas for a lot of customers. That gives our customers an option to very cost effectively implement their cannulas into current designs and then also design their cannulas accordingly to fit into new devices. We go all the way up to high volume production for customers on these cannulas as well. We have great solutions up to 16 cavity tooling, which provide a very, very cost effective part that can be produced in very high volumes, up to 40 million units a year just on one cell. This slide here just shows a little bit more about what we do on the current diabetes drug delivery cannulas that we produce. So I already touched on a few of the items here. We can produce these cannulas using a wide variety of different materials. Currently, a lot of our customers like softer materials that move around with the patient and don't irritate the skin nearly as much. We can also mold the cannulas in a lot more rigid biocompatible materials like polycarbonates and polypropylenes. So lots of different materials, lots of aspect ratios, and very customizable designs according to what you really need to be able to implement this into your current product design. Thank you.